All right, so I've given you a few minutes to think about how to do this problem. Shh, listen carefully. I started off by telling you that when you have multiple angles, when you have like 2x or 4x or 6x or 5x, then you want to try to attack that part of it using the sum and difference formulas. Try to get it down to a 2x, or let the sum and difference formulas work themselves out. In this case, we did sum and difference, and then we made a substitution over here from all the sines 2x and cosines 2x. And you see those substitutions here. I'm going to let it work out and show you how it simplifies. It's a matter of you need to practice this kind of stuff. This isn't really difficult in terms of I would never have thought to multiply or substitute that. It's a matter of trial and error for a little bit. The more you trial and error, the better you are at choosing the right thing the first time. Okay? And so this is how it all works out. So let me kind of walk you through each part. We talked here about how we substituted. You see here the yellow and the purple parts. I multiplied those together to get all of this, right? And so you see that you get 2 cosine squared x minus 4 sine squared cosine squared minus 1 plus 2 sine squared, and then minus, we multiplied all of these things together, all the like terms, and that gives me the 4 sine squared x cosine squared x. Okay? Now, here's the part where you had to think a little bit. Shh, listen. Here's 2 cosine squared, and here's 2 sine squared. That's pretty much the Pythagorean identity that I was thinking of. And so I'll bring that down over here. And I took a couple extra steps. So I factored out the 2, which leaves me with 2 times cosine squared plus sine squared, which is just 1. And so I keep everything down. Here you have the 2 same parts. So if I add those together, negative 4 and negative 4 is negative 8. That was great because that's what I remember from up top. There's my negative 8. So I come down and I bring all this together. 2 minus 1 would be 1. And then minus the 8 sine squared x cosine squared x. Okay? Now, do I expect you to have done this cold turkey without any extra help from start to finish? No, but if you could, that would have been awesome. Okay? I think some of you can, if you would have sat down and gave me a real honest effort. Okay? Now, here's the reality. Shh. You've seen it. You're responsible for it. I've shown you how to do it. I've gone through the steps. Not one step up there was unconventional. It was, here's my formula, let me plug it in and do a bunch of algebra. The most of this problem was just algebra. It wasn't trig. It was just solving equations and collecting like terms. Okay? It was a longer problem, sure. But I want you to be aware of it. I put it up here in my idea was that you can see how it works, how I would do something. This was not my first attempt. I did the problem, I didn't like how it was working out, so I went back and started over again. And the second way through, it worked out fine. There might be a better way to do it. It might be even a quicker way to do it. I just didn't try it again. I got it to work out one way, and so it was great. Okay, so there's that one. Questions? All right, so here's the problem that we've been working on for a couple of days now. Same kinds of problems. The instructions here are to solve for x from 0 to 2 pi, or 0 to 360, including 0, but not the 2 pi or 360. And I'm not really going to specify whether you get radians or degrees. I think my answers are all in radians, just for good practice. I'm going to do the left side. Just for example, I did one similar to this yesterday. I'm going to do it again just to show you. And then I'm going to give you some time to do the one on the right side. I'm looking for angle measurements, so my answers are going to be angles from my unit circle. And so here's what it looks like. Step 1 is always to substitute and get rid of my double angle. I really don't want to have to deal with the double angle when I'm solving for x. I can do that, but I really don't want to have to. And so what we do is in this case, it's nice, it's easy. Sine of 2x, there's only one choice, so I substituted that in. Step 2 would be to take this entire equation and set it equal to 0 just to get ready for the next step. And so once we do that, I have to take a minute and look at my problem. Depending on what you have, your choices may be different. In this case, factoring, and a lot of cases, a lot of ones we've done, this next step requires me to factor, whether that's traditional factoring, like x squared minus x plus 2, or in this case, like a GCF, I have only 2 terms. If I got 3 terms, I'm going to think, well, maybe it factors like a traditional factoring problem. 2 terms here, can't do that. Okay, so I'll look at it and I think, all right, well, what's common in that first part and that second part? Yeah, sine of x is common. So we're going to pull sine out and see what's left. And so you end up with something that looks like this. And this is really what I'm trying to get to. If I can get it to be this, then it's really a matter of just looking at my unit circle or using the left-hand rule to get my angle measurements right. So if I let that go ahead and play out, I said each part equal to 0. And don't go that fast. And so you see this. Right? I look at it, I think, all right, well, what are my choices? Sine x equals 0. The question you're having to answer is what angle on the unit circle has a y-coordinate of 0? And the other side would be what angle has an x-coordinate, because it's cosine, of 1/2. You can walk around the unit circle looking for those coordinates to show up. Or you could use your left hand. Okay? My recommendation is do not get totally dependent on looking at the unit circle every time. Because when you have that, when I give you the test, I'm not going to give you a unit circle. I'll provide the formulas, okay, but not the unit circle. So you need to get used to the left hand or get used to drawing it or whatever you need to do to get the right pieces that you need. I'm going to give you a few minutes. You can look at this as a model. I want you to decide how to do the second part, and then we'll come back and look at that. When you're looking at this problem, the best thing you can do is to make a good choice for which formula to use. And I told you yesterday, when you're choosing this, it's always a good idea to try to keep all the trig functions the same. So we have 3 choices for cosine 2x, right? I can do cosine squared minus sine squared. That's got mixing cosine and sine together. I've got 2 cosine squared x minus 1, and I got 1 minus 2 sine squared x. If I choose the one that's just got a cosine, then that's going to be a better choice for me. Because I can get it down and it's going to be just cosines together. If you remember the one I did yesterday, I did one just like this, but it was with sine. You're going to get 3 parts, and you're going to have to factor this like a traditional problem. So it would look something like this. So I plug it all in, you're going to get 2 cosine squared x minus 1 equals cosine x. 3 parts, guys. When you have 3 parts, something squared, something not squared, and a number, think of it as like x squared, x, and 1. So really, you should look at it like this. What? Think of it as a quadratic. And that way, you can factor it like a traditional quadratic equation. All right, here we go. Here's the rest of it. You factor like we talked about. Check your signs. You got to do trial and do the outside and the inside product. And just make sure they give you -1. Or negative cosine in this case.
I forgot how to remember if it's plus or minus. How do you
I multiplied this part, so 2 cosine x times -1. Right? So if you do the outer part, so basically what we're going to end up doing is 2 cosine x times the -1 to give you -2 cosine x. And then do the inside part to give you 1 cosine x. And you want to make sure that when you add those together, you get what was in the middle of the problem up top. It needs to give you negative cosine x, -2 cosine x. So I want it to be -2 plus 1, totally. Negative 2 plus 1 gives me negative 1. So I needed the product for the 2 cosine to be negative. That's why I made this one negative. I needed that to be positive. Once you get that part taken care of, you put it equal, set the bottom 2 parts, set those equal to 0, use your unit circle, your left hand, whatever you're used to using, and that's where you figure out your values. Right? All right, so let's change gears just a little bit. The next part, we're going to talk about the half angle identities. This is a little bit easier. So in the past, I've asked you to do this exact problem, sine of 15 degrees. Okay? The way that we did this last time was using sum or difference. You said, oh, that's easy. It's just sine of a plus b or a minus b. In this case, we used sine of 45 minus 30. Give me 15 degrees. The question is now is what am I going to do with a half angle? So the formula looks like this. You have these formulas. Okay, yesterday I put them on the board. If you didn't get those down, make sure you write them down now. Okay, sine of pi over 2, or theta over 2, equals plus or minus the square root of 1 minus cosine of theta over 2. Well, a little word about the plus or minuses. That plus or minus is determined by you. It will not be determined by the problem. It won't be determined by your work. You have to choose it. So here, it's real simple. Cosine of 15. So 15 degrees. Where is 15? What quadrant? First quadrant. So is my result of sine of an angle going to be positive or negative in the first quadrant? All positive, right? If any angle you have is in the first quadrant, doesn't matter. It's all positive. So I'll leave off the minus sign. Actually, leave them both off because it's going to be positive. I have to realize where I am. Whatever that is, whatever trig function applies, that's how I decide whether it's going to be positive or negative. And you put that in or you leave it off as you need it to be. Okay? Now, here's what happens. Look what I did. Why would I do sine of 30 over 2? Because that's 15. Here's the part that confuses a lot of people with the half angle identities. We double the angle that we're going to be investigating. But it's the half angle identity. So I'm going to be using 30 degrees in my problem because I can't use 15. So what we do is we use the angle. We're going to find out something about half of an angle that I already know. I know 30. I know 60. I know 45. I know the angles that are on the unit circle. I don't know a lot of those angles when you cut them in half. If I had 45 degrees, I don't know anything about 22.5 degrees, but I can use 45 to tell me something about that angle. And that's kind of what we're going to work out here. So basically, I plug it into the equation. Notice I got the plus sign. I don't need to do plus, but just to emphasize it. I plugged in 30 degrees. I know cosine 30, right? Cosine of 30, if you look at your left hand, cosine of 30 is going to be the square root of 3 over 2. So we're going to plug that in. And that's what you get. Literally haven't done anything fancy yet. Okay? Well, I need to simplify the answer. That's a version of the answer, not the final version. The next part is an exercise in working with fractions and square roots, which you all need practice. So yes, you have to go further with it. Okay? So what we're going to do next, I'm going to take this part, look at the top on the inside. That 1 minus square root of 3 over 2, I need to convert that into a common denominator and get that to be one fraction. So here's what it looks like. I just took the 1 and replaced it with 2 over 2. That's a piece of cake. So now I've got a common number. I'm going to pull those together, keep the top, or bring the top together, keep the denominator the same. So really haven't done anything special yet. Okay? I still have 2 fractions under radical. I really don't want that. 1 fraction, okay, not 2. So I have a fraction within a fraction. So how am I going to get rid of the 2 on the bottom? And what is that number we're going to multiply by? 1/2. Good. The 2 is on the bottom, but that's not 1/2 on the bottom. It's 2 over 1. Flip it over. Looks like this. We're going to multiply the top. What's on the bottom of my fraction? 2 is on the bottom. We're flipping 2 over because we multiply by the reciprocal. Okay? That gives you this. And I can simplify that just one more time to get this. When you have a fraction under a radical, you can take the square root of the top. Do it. Oh, no, that's the right answer. Shh, nope, that's how it works. How do we get 2 on the bottom? What's the square root of 4? I took the square root of 4. Take the fraction, put the square root on the top, put the square root on the bottom separately. If one simplifies, take it. If they don't simplify, leave it as a big fraction. In this case, I could take the square root of 4. Right? So I did. And that's how my answer works out. Okay, we're running out of time, so I'm going to put up another problem. When we look at it, tangent of 195. With 195, if I double that, I got 390. But here's the problem. 390 is gigantic, right? That's not on my unit circle. But it's coterminal with something that is. So I figured it out. I said, well, where is 390? I would like to know what quadrant it's in. So I figured out where it would be. First quadrant, that's the first thing they need to know. But you know, it's also really the same thing as 30 degrees. So I'm just going to use 30 because I like 30 better. I'm used to seeing that. And so we swapped it out here for 30 instead. And I just treated the problem like sine of 30, cosine of 30. Shh, 5 more minutes. Shh, please don't get ready. It is not, class is not over. We have 5 more minutes. This is an eternity. Okay, at least it feels that way sometimes. Okay, shh. So we're going to plug it all in right here. So what's sine of 30? It's 1/2. What's the cosine of 30? Square root of 3 over 2. Now we're back to practicing with our radicals and fractions again. We're going to get a lot of this kind of practice. So the rest of this problem, the 80% that's left is just simplifying with fractions and radicals. I want to call your attention to one specific place. When I do this and I get down to this point right here, this is one version of the answer. Okay? But sometimes you're asked to rationalize. I want to go over that with you once. So if I end up with this, and you can see here, we got the bottom common denominator. We flipped the bottom over here and multiplied times the 1/2 that was on the top. The 2's canceled out, and you're left with the 1 over 2 plus the square root of 3. How do I get rid of the square root of 3 part on the bottom? That's what we call by rationalizing. We rationalize with radicals by multiplying by their conjugate. Okay, the conjugate, smile. The conjugate is nothing more than changing the middle sign. Okay, you multiply the top and the bottom by the conjugate. You can see that here. The bottom part, it's a FOIL problem because it's 2 parts times 2 parts. So first, outer, inner, and last. You notice real quick, the outer and inner terms cancel. And so they're left with you just 4 minus 3 to give you 1. It turns out that that becomes here, and you're going to get 2 minus the square root of 3. So that is equivalent to that. You need to be able to do both of these parts. Rationalizing is something that you have done before. We've done a lot with complex numbers with I. Same exact principle here. It's just instead of an I have a square root. Exact same principle. Make sure that you know how to do those. Okay? Keep looking. Keep looking. Yes. Shh. Listen carefully. This is a quick one. We did this one, problems like this yesterday. Working with the double angle. Shh. or half-angle identities. Here, it's asking you to use the information to find cosine of 2 theta. Before I really stopped and thought about this problem, I started drawing the picture out. I was going to draw the triangle because I thought I might have to find the cosine. Then I looked at my formula sheet. Cosine of 2 theta, if I know the sine, then I can just do this and just plug it in. So what I did was I said, well, I don't need to do anything extra. I'm just going to plug that in, square that number, multiply by 2, get a common denominator, subtract the top, keep the bottom. Same thing here, except it's in radicals. When I did cosine of theta over 2, notice they gave me the sine, but I needed the cosine to do this problem. So they told me it was in the first quadrant, so I drew the triangle. I found the missing part, which helps me to find the cosine. The cosine of this angle is 4 divided by 5. Put it in here, and that's the same thing I did earlier. Simplify the problem. Here I just basically got a common denominator, combined fractions, and multiplied by the reciprocal. Notice, I could find the square root of 9, so I broke that fraction radical up, square rooted it, and then rationalized the denominator again. Now here we're going to do a verifying identity problem. You have sine of 3x equals sine x times 4 cosine squared x minus 1. To start with, we need to get rid of the sine of 3x. And so, just like we've done in the past, you're going to take the 3x, you're going to break that apart into an addition problem. So it's going to be sine of 2x plus x. Just like last time when we had cos of 4x, we broke it into 2x and 2x. In the same way, we're going to break it up using our sine of a plus b formula, which would look a lot like this. If you don't remember, make sure you go back and look at the formula sheet. And so we have sine of 2x cos x plus cos 2x sine x. And that will simplify because we can have, you can look at it in this position, and in this position we have a double angle identity. So what we're going to do is we're going to switch these things out with the double angle identity counterparts, and then we're going to try and see if we can simplify that and collect our like terms. Hopefully what we see will simplify to get what we have on the other side of the equation. So here's what you have left over, and you can see here that we've got the two parts, the double angle identities, switch out with the ones that I chose, and for sine of 2x we don't really have a choice, but it's going to be basically what you see right here. On the other side, I have a choice. I can take cos of 2x, I can make it be one of 3 formulas. The reason I chose this one, and it's really obvious because if you look up at the formula, I have the cos squared minus 1 right here. And so I'm thinking that that's the one I need to use since it's already in my solution. And it's not present anywhere else in the equation that we have down here. So we're going to go ahead and multiply what we have together. You can see in this position, I've got cosine times cosine, that's going to simplify. And then here I've got a sine outside, so I can distribute that inside to get the rest of it. And then we'll collect like terms. And so what you'll see here, I'm going to go ahead and work this out. All right, so you see at the beginning, we just basically did the cosine squared part. Here I distributed the sine of x into the negative 1 to get negative sine x, the sine of x to the 2 cosine squared x to get this piece. Right? And so kind of doing a couple of pieces at a time. So in this position, I wanted to rearrange this part so that it looked more like the part up front. Because really they're the same things. It's just I wanted the cosine to be at the end, just like the one up top. So we'll go ahead, we'll add those together, and we'll see what we have left over. So we end up with this: 4 sine x cos squared x minus sine of x. And that you just bring that on down like you had from the edge of the problem here. Just bring it down there. Then we factor out what you see here. You've got a sine x there. You have a sine x here, which is the only common part to all of that. If you factor that out, you see real simple that it basically becomes what you have on the other side of the equation here. And so that ends the problem, and This is a really good one to look at, especially because it has an odd number in for the multiple angle formula. It's not 2x, it's not 4, it's not 6, but it's an odd number, which shows me what I would get when I can take that apart using like 2x plus x.